In 1938, two Swedish immigrants in Bridgeport, Connecticut, shipped a $995 milling machine to a small casting company in Syracuse, New York. It weighed about 2,000 pounds. It had a turret that could swing 360 degrees, a ram that could slide forward and back, and a head that could tilt in any direction. Nobody outside a few New England tool rooms had ever seen anything like it. Over the next 80 years, more than 370,000 of those machines would be built. They would show up on aircraft carriers and submarine repair decks, in NASA prototype shops and Detroit tool rooms, in 10,000-square-foot job shops and single-car garages. The word Bridgeport would stop being a brand name and become a noun, the way machinists refer to any vertical knee mill, the way people say Kleenex when they mean tissue. Walk into any machine shop in North America today, point to any vertical mill on the floor, and ask the machinist what it is. Even if the casting says Jet or Acer or Grizzly, the answer will almost always be the same. That's a Bridgeport. This is the story of how a failed hedge trimmer became the backbone of American manufacturing. If this is the kind of industrial history you want more of, give the video a like and subscribe to the channel. We cover the companies, machines, and founders that built the physical world. Gothenburg, Sweden, 1897. Rudolph Frederick Bannow was born on April 15th into a country that was hemorrhaging its working class to America. By the time he was 13, his family had already crossed the Atlantic and settled in Holyoke, Massachusetts, a mill town in the Connecticut River Valley that was filling up with Scandinavian immigrants looking for factory work. Bannow finished grammar school in Holyoke and apprenticed as a patternmaker, one of the most skilled trades in metalworking. A patternmaker carved precise wooden forms that were used to create sand molds for casting iron and steel parts. Every gear, every housing, every machine frame started as a wooden pattern before it became metal. It was meticulous, physical, creative work, and Bannow was good at it. By 1920, at 23 years old, he had worked his way up to foreman at the Bridgeport Pattern and Model Works, a small shop at 143 Cannon Street in Bridgeport, Connecticut. 7 years later, at 30, he bought the company outright. His savings covered part of it. His mother loaned him $3,000 for the rest. 6 years after that, a young toolmaker named Magnus Wahlstrom would walk into the shop and change the trajectory of American manufacturing. Wahlstrom came from Surahammar, a small municipality in central Sweden, defined almost entirely by its 17th-century ironworks, Surahammar's Brook. He had worked there as a young man, first in the office, then in the mechanical workshop, picking up tool-making skills in a town where iron was the only industry that mattered. In 1923, at 19 or 20 years old, he emigrated to the United States. His first stop was Chicago, where he met Bannow through the Swedish-American immigrant network. By 1929, Wahlstrom had followed Bannow east to Bridgeport, and the two men became partners. Their first idea had nothing to do with milling machines. They spent over a year trying to develop an electric hedge clipper, a consumer product they thought could carry them through the Depression. It did not work. The hedge trimmer never became a viable product. But while they were tinkering with it, a local company called Atlas Tool of Bridgeport asked them to build something else entirely, a portable, self-contained, quarter-horsepower, high-speed milling attachment. The kind of device a machinist could bolt onto an existing horizontal mill to do vertical cutting operations without buying a second machine. Bannow and Wahlstrom delivered. In 1932, they shipped their first universal milling attachment. It was small, fast, and practical, and it sold. By 1936, they had upgraded it to a half-horsepower head with a quill, a telescoping sleeve that let the spindle plunge straight down like a drill press. Machinists loved it, but they kept running into the same complaint. The attachment was excellent. The old horizontal mills they were bolting it onto were not. Sometime around 1936, during a delivery run, Bannow pulled out a paper bag and sketched the solution. Not an attachment, a complete machine. A dedicated column and base designed from the ground up to hold their milling head. A machine that was lighter than anything else on the market, more versatile, and priced for the small shops that could never afford the massive single-purpose mills dominating factory floors. On August 8, 1938, they shipped the first one. Serial number 1 went to Precision Castings Corporation of Syracuse, New York. The price was $995. For context, a comparable single-purpose vertical mill at the time cost roughly $7,000. What made the machine different was not any single feature. It was the combination. The heavy cast iron base and column provided rigidity. The knee traveled up and down the column on an Acme lead screw, giving the machinist vertical control. On top of the knee sat the saddle, which moved front to back, and on top of the saddle sat the table, which moved left to right. 3 axes of motion, all hand-cranked, all precise. But the real genius was above the column. A turret sat on top that could rotate a full 360 degrees. Through that turret slid a horizontal ram, allowing the entire cutting head to be extended forward, retracted, or swung to any position. And the head itself could tilt in 2 planes, letting a machinist cut at compound angles without moving the workpiece. In April of 1939, Bannow filed for a patent. On March 3, 1942, the United States Patent and Trademark Office granted patent number US 2275291A. The title read, "Machine Tool Operating at Universal Angles in Overall Locations." The company had already been incorporated as Bridgeport Machines Incorporated in 1939. The timing was almost too precise. By December of 1941, the United States was at war. Factories across the country were converting to military production, and the demand for machine tools exploded overnight. The War Production Board needed machines that were versatile, fast to set up, and simple enough that newly trained workers could operate them. The Bridgeport met every requirement. It was compact enough to fit in a submarine repair shop and accurate enough to manufacture aircraft components. The factory on Cannon Street ran around the clock, 7 days a week, and still could not keep up. By January of 1945, Bridgeport had shipped its 5,000th machine. By 1948, the 10,000th. The company had completely abandoned pattern making. Every square foot of floor space was dedicated to building milling machines. In 1941, they added 2,400 square feet. In 1944, another 4,200. It was not enough. One measure of how deeply the Bridgeport embedded itself in the war effort survives today aboard the USS Pampinito, a Balao-class fleet submarine that completed 6 combat patrols in the Pacific. The Pampinito is now a museum ship at Fisherman's Wharf in San Francisco, and in its machine shop, a vintage Bridgeport still sits bolted to the deck. It was recently fitted with a donated digital readout to help fabricate restoration parts. The machine is still making chips. After the war, the Bridgeport did not fade the way wartime products often do. It became the foundation of peacetime American manufacturing. It was the first machine a new shop would buy, the tool a machinist apprentice learned on before touching anything with a computer. In December of 1951, the company moved into a massive new plant at 500 Lindley Street in Bridgeport, Connecticut. The first machine shipped from the new factory was serial number 14,476. Production milestones came faster. The 20,000th machine shipped by 1954, and the 100,000th followed in 1967. The machine kept evolving. The original M head gave way to the J head, a step pulley design with a 1-horsepower motor that introduced a tool holding system Bridgeport had designed from scratch, the R8 collet. The R8 collet was a taper that allowed for fast, secure tool changes, and it became so universally adopted that it turned into an open industry standard. Thousands of machines from dozens of manufacturers still use R8 collets today because Bridgeport designed the right answer the first time. By the late 1960s, the 2J head arrived with a variable speed drive, a continuously variable transmission that let the machinist dial spindle speed up or down without stopping the machine to move a belt. Rudolph Bannow, by this time, had become one of the most prominent industrialists in Connecticut. In 1959, he was elected president of the National Association of Manufacturers, the most powerful trade organization in American industry. A testimonial dinner in his honor was held on May 2, 1960, at a hotel in Bridgeport. He was 63 years old, the son of Swedish immigrants, a patternmaker who had bought a small shop with a $3,000 loan from his mother and turned it into the most recognized name in machine tools. He died 2 years later, in 1962, at 65. Magnus Wahlstrom took over leadership and guided the company through the rest of the decade. In 1968, Textron Incorporated, a Rhode Island-based conglomerate, purchased Bridgeport machines for approximately $101 million. Forbes magazine would later describe the deal as making Bridgeport an early victim of conglomeration. Textron expanded the brand internationally, establishing manufacturing in the United Kingdom through the acquisition of Adcock Shipley, with plants in Bridlington, Yorkshire, and Leicester. A Singapore assembly plant followed in 1980. At the time of the sale, Bridgeport employed roughly 1,000 workers. Under Textron, that number would eventually peak at around 2,500 across all locations. Textron also pushed Bridgeport into the emerging world of computer numerical control. In the 1970s, the company introduced the BOSS line, which stood for Bridgeport Operating Software System. These were standard Series 1 cast iron bases retrofitted with stepper motors on the X, Y, and Z axes, controlled by early computers reading punched tape. The BOSS 1 through 7 used stepper motors. BOSS 8 through 12 upgraded to DC servo drives. They were pioneering machines, among the first affordable CNC mills available to small shops. But the early versions were hampered by the mechanical reality that Acme lead screws, the same screws that made manual cranking feel smooth and precise, had too much backlash for reliable computer control. The technology was ahead of the iron, but conglomerate ownership brought conglomerate priorities. In 1985, Textron announced it would divest its machine tool holdings to fund the acquisition of Avco Corporation, a defense contractor. The sale closed on July 8, 1986, as a management-led buyout. Bridgeport Division President Joseph E. Clancy, backed by E.F. Hutton LBO Incorporated, paid $77 million for a 67% stake. The company was independent again. The independence was turbulent. Workers unionized within days of the buyout. 220 of them went on strike a year later. The competitive landscape had shifted beneath the company's feet while it was inside the Textron corporate structure. Bridgeport's core patents had expired in the 1960s and the 1970s. Because the machine's design was open, elegant, and relatively simple to cast and assemble, a massive clone industry had emerged, primarily from Taiwan. Companies like Jet, Sharp, Acer, Kent, Grizzly, and dozens of others began producing identical knee mills using the exact same R8 collet system, often with interchangeable parts, at prices the Connecticut factory could not touch. A Taiwanese clone could sell for $5,000. A genuine Bridgeport cost significantly more. Many of the clones were perfectly serviceable machines. Bridgeport's response was not litigation. The patents were gone. Instead, the company tried to pivot upmarket. Through the 1990s, under Clancy and later CEO Dan L. Griffith, Bridgeport invested heavily in CNC vertical machining centers, fully enclosed production machines designed to compete with Japanese manufacturers like Mazak and Mori Seiki, and with the fast-rising American competitor Haas Automation, founded by Gene Haas in 1983. But Bridgeport struggled to shed its identity as a manual machine company. The market saw them as the knee mill people, and the knee mill market was being eaten alive by clones. By 1996, employment was down to 1,024. Revenue was $209 million. The company was public, but shrinking. Then came the deal that would kill it. On April 23, 1999, Bridgeport Machines signed a merger agreement with Goldman Industrial Group, a privately held machine tool holding company based in Boston. This was not Goldman Sachs. Goldman Industrial Group was a roll-up operation that had acquired Bryant, Fellows, J&L Metrology, Jones and Lamson, Hill Acme, and Loma Machines, assembling a portfolio of legacy American machine tool brands under one roof. The deal valued Bridgeport at $10 per share in cash. The strategy was consolidation. The funding was debt. The timing could not have been worse. The dot-com bubble burst. Manufacturing orders contracted. The machine tool industry entered one of its periodic downturns, and Goldman Industrial Group's debt-loaded portfolio had no margin for error. In February of 2002, Bridgeport Machines, Inc. filed for Chapter 11 bankruptcy protection. After 64 years of continuous operation, the most recognized name in American machine tools was insolvent. On Monday, August 5, 2002, Bridgeport President Rick Clemens laid off 140 of the remaining 225 employees. There was no severance. The Lindley Street factory, the plant that had shipped hundreds of thousands of machines to every corner of the world, would close by late September. That could have been the end. For a lot of American machine tool brands, it was. But the Bridgeport was not a normal machine tool. It was the standard, and the market would not let it die. In November 2002, Hedge Incorporated, a respected precision lathe manufacturer based in Elmira, New York, signed a licensing agreement with BPT IP, LLC, the entity that had acquired Bridgeport's intellectual property out of the Goldman Industrial Group bankruptcy. By the first quarter of 2003, Harding was building genuine Bridgeport Series 1 knee mills in Elmira. In 2004, they purchased the Bridgeport name, trademarks, designs, and intellectual property outright for $7.25 million in cash plus $4.1 million in finished goods. A final purchase of all remaining technical information closed on January 27, 2006. Hardinge's CEO at the time, J. Patrick Irvin, understood what he had bought. The industry for small parts manufacturing, he said, was founded on Harding lathes and Bridgeport mills. You cannot go into any quality job shop in North America, he continued, without finding a Bridgeport knee mill and a Harding manual lathe standing side by side. The Elmira operation was a case study in lean manufacturing. Modern Machine Shop reported that Harding achieved 75% of the old Connecticut factory's output capacity in just 10% of the floor space. But the pattern of ownership instability continued. In September 2023, the Bridgeport brand was acquired by Encompass, a platform company backed by TJM Capital Partners. And on July 29, 2024, Harding Incorporated itself filed for Chapter 11 bankruptcy in the U.S. Bankruptcy Court for the District of Delaware, carrying approximately $106 million in funded debt. The filing cited a failed sale of its Chinese subsidiary, blocked by Chinese securities regulators, and losses tied to its 2021 acquisition of German manufacturer J.G. Weisser. The Bridgeport Series Y is still in production. That fact alone tells you something about the design. Rudolph Bannow sketched it on a paper bag in 1936. It went into production in 1938. The fundamental geometry, the knee, the column, the turret, the ram, the articulating head, the quill, has never been meaningfully improved upon. Not because nobody tried, because nobody needed to. The machine's cultural footprint is unlike anything else in industrial history. Trade schools and university engineering programs still teach on Bridgeports because the machine forces a student to understand what is actually happening when metal cuts metal. There is no screen between the operator and the physics. You feel the feed pressure in the handwheel. You hear the chatter when the speed is wrong. You learn the difference between climb milling and conventional milling by the way the table pulls. That tactile education cannot be replicated on a CNC. And the secondary market is enormous. Because more than 370,000 of these machines were built over 80 years, there is a constant supply of used Bridgeports circulating through auctions, estate sales, and online listings. Hobbyists, gunsmiths, car restorers, and prototype engineers buy them for their home shops. A vast ecosystem of aftermarket parts, digital readout kits, power feed units, and restoration services exists solely to keep decades-old Bridgeports running. Meanwhile, at the professional level, virtually every advanced CNC shop in the world still keeps at least one manual Bridgeport somewhere on the floor. The reason is simple. A CNC machine is faster at making 1,000 identical parts. But setting up a CNC program to drill a single hole in a broken fixture takes longer than walking over to the Bridgeport and doing it by hand. For tooling, fixturing, one-off repairs, and prototype work, the manual mill remains the fastest path from problem to solution. The factory where they were built is gone. The 500 Lindley Street complex stood vacant after the 2002 shutdown. Demolition began in 2010. Today, the 7-acre site at Lindley Street and Capitol Avenue in Bridgeport, Connecticut, is an empty lot, marketed as a mixed-use light industrial development opportunity. There is nothing there to tell you that the most successful machine tool in history was once assembled on that ground. Magnus Wahlstrom died on January 30th, 1972, 10 years after his partner. In his later years, he had become a quiet philanthropist in Bridgeport, paying rent and buying groceries for people who needed help. He served as a trustee of the University of Bridgeport. In 1974, 2 years after his death, the university opened the Magnus Wahlstrom Library, a 4-story building overlooking Long Island Sound. It remains the campus's main library today. His name is still on the wall. Bannow's legacy is different. It is not on a building. It is on 370,000 castings, scattered across every continent, in shops and garages and schools and submarines and factories, still cutting metal, still holding tolerance, still doing exactly what a Swedish immigrant and a pattern maker designed them to do on a paper bag 90 years ago. If you want to see how another American company built a machine that defined an entire industry, give this video a like and subscribe. See you in the next one.